Hello, my name is Casey Findell, and I'd like to give you a brief overview of the term project for Geography 897C, Cloud and Server-Based GIS, through Penn State University's Master in GIS program. I chose to focus on an automated meter infrastructure deployment program at a local utility, electric utility, and specifically creating a prediction model to aid in the deployment of such a program. The goals of the project were fairly straightforward: create a web-based application for viewing automated meter infrastructure behavior, use a Python script to calculate and write AMI meter behavior values and help select collector meter locations, and create a tiled cache mapping service to improve drawing speed, symbolization levels, and of course we wanted to allow editing within this application. Amazon EC2 servers provided the base for this entire project. The instances were various scales for different needs throughout the project. ArcGIS for server, specifically Cloud Builder, was used heavily. FlexViewer was responsible for the final portal of web viewing. And of course, the Python programming through WinPy was extremely important. Data sources and behavior parameters came directly from the electric utility that I work at, and this project in its final state is already in use there. Basically what we're trying to do is set a centralized collector meter to gather and relay the read information for an area of meters. So you may have 80 to 100 of these collector meters throughout a system of 40,000 meters. All meters can communicate up to 1,200 feet, and they can hop up to 8 meters to reach this collector meter. Many learning opportunities were present. Python script required a few different trials on different level of instances on Amazon to get it to run correctly. Finally ended up with an M3 2 extra large, and it took about a day. Symbolization was very tedious, especially when using a tiled cached map service, but the benefits far outweighed it when compared to a basic MXD map service. And of course, all the IT hurdles and networking hurdles without your IT person to lean on. So now I'd like to take you over here to Python and just show you the script real quick. If you're familiar with Python, you'll see it's a basic select and write and select and write 8 times script. Let's head to the server. I'll show you that I created 3 services for this project. Most important one would be the tiled cache service, and the other one that was used was the feature service for editing. I did create a basic service and ended up not using that because of the benefits of the tiled cache system. So let's go over here to our map. I'm going to refresh this so you can see how fast it draws and what extent it comes in at. So here we are at full extent. We're looking at the full service area of our utility, and we're looking at the 8th hop. Red would be a lower value in how many meters can be seen from that point, and green would be a higher value. So let's zoom in on one area and see how fast this draws, which is pretty quick, I believe. And we can kind of see the action of the script through here as we scroll in, and you can see that you have a halo now because I've symbolized the 1st, 4th, and 8th hops. And I put the 8th hop right on top there, identified the location with a meter number and our primary key and the phase. And that'll help the metering manager. Importantly too is to be able to add some notes. So maybe we like this one. What's interesting about this one here that I'm about to place on is that it is yellow, so it's a lower value on the 1st hop, which is a larger one, but as you get out to the 8th hop, it's actually in the highest class of green. So we might say good spot. Being on the edge like this, I don't think this would be a final candidate, but it's not a bad one. And of course, while we have that open, we're able to look at other edited areas. Thank you very much.